Okay, the first thing we're going to be doing today is breaking down the pieces and the parts of a box plot. So we're going to start with labeling each of the boxes down at the bottom. So if we have the number that is the smallest, that is also known as our minimum. Okay, and then on the opposite end, the number that is our largest, that is our maximum. And then a number that we've talked about in the middle, which is going to be the middle of our data, is going to be median, also known as quartile 2 or Q2. Okay, then if I broke down this half of data into another half, I would find my quartile 1. So this is quartile 1, the median is quartile 2, and then making our last part quartile 3. Okay, if you look on this paper, it is broken into 1 box, 2 box, 3, 4. And each part of this data is worth 25%, and that is up here. 25% of the data. So what we are going to do is we're going to color. So you need 4 different colors of colored pencils or markers. I have some set out for you. You may pause and go get that or use your own. We're going to color the first 25 blue or whatever color you have. Just pick one color. And then the next part then the top part that goes with it, because the lines go together, we're also gonna color blue. This is our quartile 1, the whole thing. The whole thing is gonna be quartile 1. Okay, and if you look up here, we have a number line. And each of these numbers down here, 0, 1, 8, and 22, fit between 0 and 25, which is our cutoff line right here. That is our quartile 1, and it is worth 25%. That's where quartile 1 line ends. So if I were to mark on a graph or on a number line where my minimum is right here. Okay. And then finding quartile 1 would lead us right here to 25. And then my next part of my data, which is also worth 25%, is going to be my quartile 2, which is this middle box. And if you look between here, we have 28, 29, 31, and 34. Those are all numbers that are between 25 and 35. Finding our middle. So I'm going to take a different color. I'm going to color the 25 that color. And then color this box above it as well, the same color. Make sure it's a different color than the quartile 1 or the first box. Okay, and we're going to go ahead and label these. We're going to label this whole box quartile 1, ending with my quartile 1 box right here. This is going to be quartile 2, ending with our quartile 2, ending in our median, the middle part of our data. And then we have quartile 3. Use a different color to color our 25. Okay, and then I'm going to color the top part as well. Making sure it matches so that way I know that my box plot is going with this 25% of my data. And if I put all of my numbers on a number line, the numbers that go in this box are between 35 and 55, And that would account for down here, 36, 40, 51, and 53. That's going to be quartile 3. Ending in my quartile 3 dot. Okay, and then last but not least, we have quartile 4 that's representing the last 25% of my data. Okay, which would be down here or up here. So then I have quartile 4. Ending in my maximum. Okay, so we have quartile 1, which is from minimum to the first part of our inner quartile, which is this box. Okay, I also want us to go look down here. It labels inner quartile, and that is between quartile 1 and quartile 3. Okay, when we're talking about the percentages, we are talking about the different parts of our data, not the numerical worth of the numbers, but how many data points we have. So if we look between our minimum and our quartile 1, or the first 25% of our data, we have 1, 2, 3, 4 numbers. Then if we look at our next part of data, the next 25%, quartile 2, there's 1, 2, 3, 4 numbers. Then we break it up again into quartile 3, which is the next 25%, 1, 2, 3, 4 numbers. The last quartile, quartile 4, break it up, 1, 2, 3, 4 numbers. So I split all of my data points into 4 equal portions or data points into my box plot. On your notes video, we are going to have more work on box plots and how to make them, but these are just the pieces of each box plot. We have quartile 1, quartile 2, or our median, quartile 3, and then ending quartile 4 in our maximum and starting with our minimum. So we have minimum right here, or 0, then quartile 1, then our median, quartile 3, then our maximum. Each of these represent a dot that is above on your number line. Okay. So now you're moving over to your notes packet. You will keep this paper in your folder. Okay, these are going to be your box plot notes. Please follow along. Take all the notes that I do because I do expect you to have them filled out when I return. Okay, a box plot displays data distribution using 5 key numbers. The difference between the first and the third quartile is called the interquartile range. We've talked about this before. It's called the IQR. This is Q3 minus Q1 equals IQR. Okay. The next thing we have is the minimum. That's our smallest piece. Sometimes you'll see it written as min. Then we have our first quartile. You could also see this written as Q1. Okay. Then we have, that's the median of the lower half of data. Then we have our median, which is the middle of the data. Also seen as Q3. Or Q2, sorry. Q2. The median, that is the midpoint of data, very middle. Doesn't change from what we've been doing. And then we have the median of the upper half of data, which is the third quartile. Which is also seen as Q3. And then we have our largest piece of data, which is the maximum. You could sometimes see this as max. Okay, and then we're gonna label our data points below. So this on the very left-hand side is gonna be our min, or our minimum. This first part of this box, that's Q1. This middle line right here in the middle of the box, that's our median, or our Q2. And then the last one is our Q3. Okay, that's the part of this box. Very end point is going to be our maximum. That's just the largest piece of data. Now we're going to go down and we are going to work these two out, finding our minimum, our quartile 1, median, quartile 3, maximum, and then we're also going to find our IQR. So if we put our numbers in order from least to greatest, because that's what we need to do first to find our minimum and maximum, and then our median. Our minimum, or our smallest number, is 34. And then we have 45, 34, 45, then we have 47, then 48, that one's there twice, we have 49, and then 50. Okay, so our minimum is going to be our smallest number, so that's going to be 34. Our maximum is 50. Okay, I'm going to place these two dots on our number line below to make our box plot. So 34 is going to be right here before 35. And then I'm going to place 50 down here at this end. We're not going to do anything with these dots yet, just place them on our number line. Okay, then we have, let's find our median. That is the next easiest one. If we mark out high to low to find our middle number, it's going to be 48. And then from there, we use our left half of data and our right half of data to find our Q1 and Q3. Q1 is found in our left half, or the first half, which is the median, which is 45. And then Q3, or quartile 3, is in the second half of data, which is 49. Now we're going to place all these points. So we have 34, and then we're going to go to 45, which is all the way down here at the end. And then we go to 48, which is 3 lines after 45, and then 49. Okay, now what we are going to do is the middle 3 dots, we're going to draw a box around. And then we're going to connect our minimum and our maximum. These could also be called our outliers. They're outside of our inner quartile range. Right in here, in this box, this is our inner quartile. To find the inner quartile range, we subtract Q3 minus Q1. So that would be 49 minus 45, and we'd get 4. So our IQR is 4. Because there is 4 dashes, or 4 numbers, between our Q1 and our Q3. 1, 2, 3, and then 4. Okay, now we're going on to number 2. The following data set represents the number of hours a small candle will burn. Again, we're going to make our box plot. We have to find our 5 numbers to make a box plot, and then at the end we're going to do IQR for practice. Okay, so if we put our numbers in order from least to greatest, our least is 7, and then we have 8, and then 9, 2 of those, and then a 10, and 2 11s. And then 12. No 13, so we go all the way to 15. We have 2 of those. Oh, 14, sorry. 14, then 15. We have 2 15s. And then 16 and 19. Kind of ran out of space. So 14 right here in the middle. Okay. So our minimum is going to be the smallest number we have, which is 7. And then we're going to find our max. That's the next easiest, which is 19. Then we have to find the middle of our data. So I'm going to use 1 dash above each of the numbers so I can still see my numbers. There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 11 is our middle on the in the middle. That's our median. Okay, then from 11, I have 2 halves of data. Our left half, or our first half, and then our right half, our second half. We're gonna find our Q1 and our Q3. So if I go through and mark out, there's going to be 2 in the middle here. If we do 9 plus 9, that's gonna be 18, and then we divide by 2, which gives us 9. So 9 is our Q1. If we ever add the same number together and then divide it by 2, it's going to get us back to that same number. Okay, then we have our next half of data. And 15 and 15 become our 2 numbers in the middle. 15 plus 15 is 30, and then we divide it by 2 is going to get us back to 15. So now we are going to place our numbers on our number line. We have 7, which is right about here. Then we go 9, which is right before 10. Then 11, right after 10. 15. And then 19, right before 20. Now, I box my middle 3 points. Draw a line down my median, the middle dot in the middle of the box, and then I draw a line to my outliers, my minimum and my maximum. Okay, between these 2 dots are boxes. We have 1, 2, 3, 4, 5, 6 numbers. That's our interquartile range. That can also be found by doing 15 minus 9 equals 6. Okay. That's number 2. Number 3, it says use the given box plot to determine the 5 numbers summary. So we're going to find our minimum. Our minimum is going to be that line on the very left-hand side. So that's 11. Quartile 1, it's between 11 and 14, but it's closer to 11, so we're going to say it's 12. Our median is right on 14. And it goes in order. Our quartile 3, it's between 14 and 17, but it's closer to 17, so we're going to say 16. And then our maximum at the very end, it's closer to 17, so I'm going to say it's 18. Okay. We could still find our IQR using this data because we could do Q3 minus Q1, 16 minus 12 equals 4, and that equals my IQR. Okay, interquartile range. Now, go to the next page of our box plots. Okay. We are going to use our knowledge of box plots to answer the questions below. It says, Christina conducts a poll to determine the number of colleges high school seniors applied to. Then she creates a box plot to represent this information. It says, determine the range of the number of colleges. So, our range is going to be our smallest number and our biggest number. We're going to find the difference. So I am going to label each of my points. I have 0 here and 9 down here. And while we're at it, let's label our Q1, quartile 1, which is going to be 4. Our median, which is 6. And then our Q3, which is 8. Okay. So we have determined the range. Range is the biggest minus the smallest. So we have 9 minus 0 equals 9. So 9 is the correct answer. Okay. Number 5, what is the median number of colleges? Well, we just found that out. Up here, the median is in the middle of our box plot, which is going to be 6. We've already determined that right here. Okay. Number 6 is the interquartile range, or what is the interquartile range of the number of colleges? Interquartile range is Q3 minus Q1 equals IQR. So we're going to plug in our numbers that we know. Q3 is 8. Q1 is 4. 8 minus 4 is 4. So 4 is our answer. 4 is our interquartile range. Okay, and then number 7. Which quartile represents the greatest spread in data? Spread means gap. Or space. Okay, on this graph, we can just look at the ranges. So we have from 0 to 4, 4 to 6, 6 to 8, or 8 to 9. And we can see which one has the most space. So if I look between 0 and 4, that's going to be 4 numbers here in the middle of this. Okay, between 4 and 6, there's only 2 numbers because 6 minus 4 is 2. Between 6 and 8, there's also 2. And then over here between 8 and 9, there's only 1. So the greatest spread, which is also the biggest space, is going to be in this first part, which is going to be 4 colleges. And that's going to be our first quartile. Okay. And now number 8, it says describe why quartile 1 is larger than quartile 4. What do you observe about quartile 2 and 3? So we notice that quartile 1 is larger because the lowest (25% of the data is more spread out. Okay, and then quartile 2 and 3 are equally distributed. Because there's the same number of numbers between each of the spaces. Okay, now we're gonna move down to number 9. Sorry if that was cut off. Number 9. It says the average monthly rainfall during the summer months and winter months are shown below. So we have both of these and we're gonna look at both of them. It says the range of rainfall in the winter, was 12. So we're just looking at our winter. We're gonna go from right here to right here. This is gonna be 3 and this is gonna be 5, or 15, sorry, 15. And I have to find out my difference. So 15 minus 3 equals 12. So that is true. Okay. The next one, the median rainfall in the summer was 13. Median of the summer, 13. So if I look at my summer months, and look at my median, it comes right down in here to 11. And 11 is not 13, so this is false. And we're gonna write median equals 11 to make it true. Okay. For the next part, it says for half of the months in the summer, the rainfall was greater than 11 inches. So we know that between here and here is 25%, and here is 25. So add that together, that's 50, because on one half of our data is 50%, the other half is 50%. So we're looking at the summer, and we're gonna see if for more than half it was greater than 11. So from here all the way to the end is 50%, and that is half of the months, and it's 11 or more. So this is true. Okay. Then we have for half of the months in the winter, the rainfall was less than 10 inches. So we have the winter, less. So if we look at half, which we know is the first two quartiles, this is 50%. And it's less than 10 inches right here is 10. So that is also true because half of it is less. Okay. Now we're gonna go to, or for on level, this is where you will stop. You will go ahead and go on to your practice. For honors, we are moving on to the next page of comparing box plots. Again, on level, if you are still here, you will not have this page. Honors, this is page 14 for you. Okay, so we have comparing box plots. A local election on a school bond is proposed to fund a natatorium. Alex conducts the exit poll in which he asks voters to share their age and whether they were for or against the school bond. He then displayed this in box plots. So we have our for and against, and each down here is the age of the voters. So it says, what is the difference in the measures of center of the voters who are against the natatorium? So the difference of the voters who are for and against. So we're going to look at our measures of center, which is our median. Our median is right here. On both of them is the middle line. For, it would be 31, 2, 3, 4, 5, 35. And against would be 49. So we're looking at the difference. So we'll do 49 minus 35. 9 minus 5 is 4. 4 minus 3 is 1. So the 14 year difference. Okay, so you see we looked at both of them, we found out what they needed in each one, and then we found the difference. Now it says determine the IQR of voters, or the interquartile range of voters who voted against the natatorium, and determine the IQR of voters who voted for. So we're gonna write IQR against, and then IQR for. That way we can keep our answers separated. So the interquartile range, that's this shaded box. That's in the box plot, that is our box. What is between the two ends of the box? So for 4, I like to draw these lines down so that way I can see the numbers. We're gonna say this is 28. And 42. So IQR is Q3 minus Q1. So we have 42 minus 28. We can't do 2 minus 8, so we have to borrow 12. This can become 4. and 3 minus 2 is 1. So our IQR against is 14, and the IQR, 4. Sorry, switch these. I'm just gonna mark this out. This is why we use pencil. IQR against. So this will be 14 for 4. And then to find against, if I will look at the right graph this time, we have 40. And then we're gonna say this was on 60 to make it easier. 60 and 40. So 60 minus 40 equals 20. So it's gonna be 20 against and 14 for our interquartile range. Okay, now it says complete the statements below. So it says the range in age of voters for the natatorium was blank, and the range in age of voters against the natatorium. So the range and the voters for was blank, the range in age against. So we're comparing. So the range of 4, and we're gonna use the range. So range for 4, we have to find it. Sorry, I was making sure we didn't have it already. So we go from, we'll say this is 52 and 20. Oops, sorry. So then this is 20 and 1, 2, 3, 4, 5, 65. So 52 minus 20 for 4 is 32, and voters against is going to be 65 minus 20. Which is going to be 45. So the range and age of voters 4, and then against 4 was less than the range and age of voters against. Okay, then we have the data for voters blank. The natatorium was more symmetrical than the data of voters for blank. So symmetrical is where we look at the spaces between each of the quartiles. So against, we have this long line before getting to our minimum and our quartile 1, but then we don't have another long line on the rest of them. This one right here, between each of these, is about the same. Making it more symmetrical. So the data for the natatorium or natatorium was symmetrical, more symmetrical than the data for against. Okay. Sorry, that was a bit much on this first one. I got lost. Now we have number 7. Number 7. It says a survey was conducted to determine the average price of a movie ticket in Kansas and New Jersey. The data was displayed using the box plots shown. So using both of these, we're going to answer all 3 questions. What was the median cost of movie tickets in each state? So we'll do Kansas first because it's on top. And the median, we'll say is 10. Okay, and then we have New Jersey. I was just making sure it was only 5 between. Is going to be $11. Okay, which state has a wider range in variability? So that means which one has the bigger gap in our minimum and our maximum. Minimum and maximum. So for Kansas, our minimum is 3 and our maximum is 15. So this one's 15 minus 3 is 12 is our range. And then for New Jersey, we'll say it's 5 to make it easier. And 19. This is going to be 14. So the wider range and variability is in New Jersey because it asks why. The range is wider or larger. Okay. And then see, a moviegoer spends $14 on a movie ticket in New Jersey. What can you conclude about the price the customer paid? So $14 in New Jersey, which is about right here. We could say that is around average, but above the median. And we would say this because it's still within our interquartile range, which is where most of our data points are, but it is more than our median, which is going to be 11. Okay, please make sure that you have all your work shown for this and then go on to your practice for honors. Thank you.